Hi guys and gals and kittens, and welcome to the Magic Show. In this video I'm going to show you an alternative to VSS, vector semantic search, to retrieve RAG data or contextual information to the LLM. RAG meaning retrieval augmented generation. And in case you don't know how this works, basically every single time you phrase a question to the LLM, then the cloudlet does RAG retrieval of contextual information based upon VSS search, which is basically like AI search if you wish, and then transmits context to OpenAI as it's answering questions. And this is what allows us to use OpenAI and answer questions based upon your data. Your CEO question mark. Now, if you go to our chatbot at ineru.io, you can see me. If you ask who's your CEO, it correctly knows. Okay, we're talking about ineru here, right? This is because it's actually retrieving contextual information that it uses as RAG using VSS. However, RAG is fairly expensive, not like monetary wise, but you know, from like a CPU or a computing point of view. And it's also very, very bad at finding the needle in the haystack, literally. Now, for those cases where you need the needle in the haystack, so to speak, there is an additional new method that I refer to as distinct keyword density count. Now, instead of me explaining it, let me just use the generator here, choose my Chinook database, and make sure I have the search bugger down here checked off. It's still beta for the record, so it's not mature. And it's not going to be released before earliest this Sunday. As you can see, the system produced over 10,000 lines of code for me automatically. Now, if I expand modules in HyperID, and I find Chinook here, and I filter on search, then you see customer search.get.hl. Now, let's find some relevant customers by opening up SQL Studio in a different tab. Choose our Chinook database, select all from customer, limit 100, and let's find some customers we can do a search for. So we can search for Helena, we can search for Astrid, or we can search for Dan. Now, if you look at Dan here, for instance, you will see that he works for Apple, right? However, if you look at Helena here now, you will see that she does not work for Apple. She's got a Gmail address. So now I want to look for an Apple employee whom I think was named Dan or Helena, right? Okay, so now let's trigger that bugger. Dan or Helena and Apple. And as you can see here now, it prioritizes Tim Goyer. Why does it prioritize? Because he's got it in company and he's got it in email and etc. However, here you see we have a guy at Apple here. Then we have a guy. Then we have Helena here because we added Helena. And then we get the Dan and Apple down here. Now, if we search for Dan and Apple, then you see Dan scores higher. Why? Because two of my keywords are found. We found Dan and we found Apple. While Tim Goyer only has Apple. While Ladislav only has Apple. While you here only has Apple, etc., etc. Now, if we add you to it, Helena, Apple, you, then now you will see you, O'Reilly, scores at the top. Why? Because all three keywords are found in that record in one of the textual-based fields. Now, first of all, this is ridiculously fast. I mean, bloop, right? There's no embeddings created for my question whatsoever occurring in this logic, and it's much less CPU intensive or like, you know, costly in regards to how much computing power it is using in comparison to embeddings, which is like really, really expensive, right? So now let's just go to manage. Let's go to machine learning. Let's create a test model, test very, very creatively. Let's turn it into an AI agent. Save it. Let's add some AI functions to it, add functions, okay. Search, customer, search. Now I find the file that allows me to search for customers. Install, save. Now if I open up my expert system and I choose the test type here now, then if I write I want to search for customers working for Apple, I'm looking for a specific customer. I think his or her name is Helena or Dan. Ta-da! Now look into the log here of the machine learning type here now, in the history tab here now. We look here now. You see it performs a search for Apple, Helena and Dan. And here you can see the result. Dan, Apple, Apple, Helena, and why did you come? Because he works for Apple. He's got an Apple email. Isabel has an Apple email, etc., etc. And as you can see now, it finds Dan Peters, scores him at the top because he fulfills both criteria. He has an Apple email address and his name is Dan. While Helena scores number 2. Why? Because she only has a name matching Helena and she doesn't have Apple anywhere within her customer record. So this actually is much more accurate for finding the needle in the haystack problem than VSS search. Why? Because VSS search doesn't care about keywords whatsoever. So, but this one actually does a keyword density matching towards your data foundation using every single column in your table, allowing you to use it as an alternative to embeddings and VSS. And I think that's pretty kick-ass. For specific searches where you're looking for one very, very exact thing and you have keywords you can associate to look up that specific exact thing, this is basically 100 times more accurate than VSS search. And to use it as your RAG foundation simply improves the ability for your LLM to retrieve the correct records according to your instructions by like 1,000 times or something. So, and yeah, it can be used on any table, any table. If I now go back here now and I find, let me see, HyperID, let's find modules, Chinook, search, album, search, okay. I'm looking for an album. I think it will. I'm searching, I probably need to write search. I'm searching for an album. I think it was named something with black or back. Now, of course, hopefully it's going to be returning and it didn't find any albums. Let's figure out why. Machine learning, history, edit, and this guy. List albums. Okay, that's not the guy we want to use. Use the search function. Ah, we didn't install it. Of course. Types, test, and function. Album, search, install, save. Let's just refresh here to simulate a new session. And there we are. Back to Black, Black Album, Black Sabbath, Backbeat Soundtrack, Black Light Syndrome, Black Sabbath, etc., etc. Now, if we now change this to with, I think it was named something with black or back or light, and backlight is going to bubble upwards. Why? Because it contains all 3 keywords, or 2 of them. Black Light Syndrome. And then comes Black Sabbath, Black Album, etc., etc. Anyways, that was it for today's video. Thank you for watching. Have a nice day.